Okay, moving on. Uh, this, I can't tell what question number it is. I believe it's question 3. And this is kind of the newer class of equations that we've been looking at. And they give us an opportunity to consider some of those tools that we've been talking about in class, looking inside, rewriting portions of the equations, undoing things, also fraction busters. So let's look at part A first. And one of the things I do know is that I know some arithmetic, and for sure I know that the 8 squared is 64. Or in other words, the square root of 64 is what gives me 8. So on this problem, I know that this thing inside that I've highlighted in yellow must be the number 64. So I'm going to write that fact down, right? This 12x plus 4 must be 64. And if it is 64, right, then it will produce a value of 8. So this is what we've called looking inside. I'm looking inside the radical symbol here. If I take away 4 from each side, I get that 12x is 60. And if I divide by 12, um, 60 divided by 12, I believe, is 5. So when I put 5 into there, right, 12 times 5 is 60, plus 4 is 64, and the square root of that is 8. So this is most definitely our solution. If I look at part B, um, the one hope that we have, because we haven't discussed logarithms or exponential versus logarithmic forms of equations, we've just been using this notion that if I can get the bases to look the same, it has to be the case that the exponents must be equal to each other, right? Kind of looking inside the exponents, they have to be the same. So fortunately, 125 is 5 to the third power. So I can use that fact and rewrite this 125 as 5 raised to the third power. So those two things are equivalent to each other. Now I'm taking that 125, also known as 5 to the third, and I'm raising that to the x minus third power. And over on the other side, I've got 5 to the x minus 1 power. So one of the things you might consider here is when you raise a power to a power, what happens? Um, Maybe you don't know, right? Maybe you're like, I have no idea, you know, and then you start asking things like, do I multiply? Do I add? What I? So if you're stuck and you're still not at a point where you've got that memorized, just consider something, right? So look at, if I have 2 to the third and I raise that to the fourth power, the question is, how many factors of 2 are represented here? Well, I know that I have 4 of the 2 to the thirds, right? I've got 1, 2, 3, 4 of those. And every single one of those represents 3 factors of 2, right? 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. Well, if you look at it, this is repeated addition, right? What I've got here is 3 plus 3 plus 3 plus 3, which is 12, right? So again, the rule, which is worthy of using because writing this out and thinking about it all the time gets cumbersome after a while, is if I have a raised to the b power and then that's getting raised to the c, that's equivalent to a to the b times c power. So I need to multiply. Well, what does that have to do with this problem? Look at, I've got this x to the third that is the exponent for 5 to the third. Well, what do I do with this 3 and the x to the third? I'm going to multiply them. And I need to push that factor of 3 into both of those terms. So I can rewrite this as 5 to the x minus 1, and it's going to equal 5 to the 3x minus 9. You see what I've done there. Now, the beauty is the only way, and honestly, the only way that these can be equal, right, with these bases of 5, the only way equality is possible is if their exponents are equal. So I'm looking inside the exponents here and I'm saying, look, x minus 1 has to be the same thing as 3x minus 9 if these are indeed truly equal. And to solve that, I'm going to take away an x from both sides. and I'm going to add 9 to both sides. So I get 8 is 2x, and when I divide both sides by 2, I can see that x must be the number 4. So when x is 4, it will be the case that 5 raised to the x minus 1 power is the same thing as 125 raised to the x minus 3 power. And again, that's something that you can definitely grab your calculator and verify. Finally, this last problem, I'm going to use fraction busters, and what I'm going to do is multiply both sides of this by 2x. And to do that, I'm going to space it out a little bit. So I've got 3 over x and then plus 5 over 2, and that equals 7 over 2. So you can see I'm multiplying by 2x. So this is going to become a 2x over 1 times 2x over 1 times and a 2x over 1 times. Well, what's nice about this is I am forming some giant ones, right? There's an x over an x, there's a 2 over 2, which equals 1, and there's another 2 over 2, which equals 1. Well, if I ignore those ones, right, and why not? Because multiplying by them doesn't ever get you anywhere. I end up with the equation 6 plus 5x, and it is x times 5, but I just rewrote it as 5x, equals 7x. So 6 plus 5x equals 7x. If I take away 5x from each side, I've got that 6 equals 2x, and if I divide both sides by 2, we can see 3 is what we get for x, right? X is 3.